Okay, so 17.2, here we go. What we're doing in 17.2 is we're going to describe the amplitude, the period, the phase shift, and the vertical shift of any sinusoidal wave, sine or cosine. I have two standard form equations here. We have A times sine of B times x minus c, and all of that we're going to add d to it. The other standard form is essentially the same thing. It is A times cosine, B times x minus c, and we're going to add d to everything. Now, just like the quadratic formula that you guys know so well, a squared plus b squared equals c squared, your a, your b, and your c stand for something. There's just not a letter. Same thing here. Your a, your b, your c, and your d are going to represent something, and you're going to use it to actually help describe what's happening to the regular sine wave, the parent function of the sine wave. I'll do another video on showing how to actually graph these sine waves, but right now I'm just going to concentrate on explaining how to describe it. When we start with A is the number that's directly in front of your sine or your cosine, right here and right here. It could be a positive number, it could be a negative number. But we use A to find our amplitude. We're going to do the absolute value of A is going to equal your amplitude. Now we've talked about amplitude. That's actually from the middle part of the wave to this maximum and to the minimum. It's going to be the same distance. It's going to be positive because it's a distance. You always have a positive distance. But you're going to use the letter B right here and right here. B is the number that you're going to be basically multiplying x by. You're going to use that to find your period. Well, your period right here is an equation. It's 2 pi divided by the absolute value of b. Now, period is still a distance. It's how far does it go to repeat. The standard period of a regular wave is 2 pi, simply because it's based on a circle, and a circle starts to repeat itself after 2 pi, which is 360 degrees. C is called your phase shift. You guys already know what a phase shift is, but you just don't know the terminology. Phase shift is basically, do you move the wave to the left or to the right? Left, right, left, right. Phase shift is just a fancy way of saying a left movement or a right movement. Your D is your vertical shift. Your vertical shift is moving up or down. It's going to change your Y's. Your Y's is either going to go higher or it's going to go lower. So let's look at an example here. We have 3 times sine of 4 times x plus pi minus 4. So we're going to go in and describe what's happening to this wave. Well, right off the bat, my amplitude is going to be A, which is right here at 3. I'm going to take the absolute value of 3, which is nothing more than 3. So the amplitude of this wave is 3. My period is a simple equation of 2 pi divided by my b, which is right here, is the number we're going to multiply by x. So we're going to divide it by 4. Of course, we have to reduce our fraction, and this ends up being pi over 2. My phase shift meaning it's going to move left or right. Now, you have to have your rules with your transformations. You have a little table, you can look at them, but remember, inside your parentheses is going to be opposite of what you think. If it's plus, you want to say it's going to move to the right, but really, it's actually going to move to the left, that direction. You're going left by pi units. The minus 4 right here, that's your D. And that is going to affect your Y value. That means you're going to go up or down. And this is going to be face value. This is a minus 4, so you're actually going to move it down 4 units. And this up here was pi units. Pretty straightforward process until we start throwing fractions into it, because I know you all love fractions. So now let's take a look at one with fractions. Let's just say we have 1/4 cosine of 2 over 3 times x minus, say, pi over 4 plus 3. That equation looks a whole lot uglier than the last one we just did. But it's the same process. To find your amplitude, you take your a, which is your 1/4 right here. You want to take the absolute value of 1 over 4? Well, that's just simply 1 over 4. So your amplitude is 1/4. Your period, on the other hand, gets a little interesting. Your period, you still need to take your b right here, which is a fraction, and you got to put it underneath 2 pi. Well, I'm going to use the idea that 2 pi is also a fraction. It's 2 pi over 1. So I'm going to do 2 pi divided by 1 divided by 2 over 3. And I know it looks scary. It looks like a hot mess, but we use that rainbow that we've done in class. We do 2 pi times 3. That is your new top. Follow this top arc. That is your new top. So we do 2 pi times 3 gives me 6 pi over, do your middle arc. This is your new bottom. 1 times 2, pretty straightforward, is 2. Then, of course, we reduce this. 6 pi over 2 is just going to simply be 3 pi. So the period of this actual wave is 3 pi. Can't see that right off the bat. You have to do a little bit of math. Now, as far as your phase shift right here is telling you it's -4, so it's actually going to move to the right. You're going to move to the right pi over 4 units. And then right here, your d, you just simply move up 3 units. Now, it looks like a mess, and you can go in and clean it up. This is just kind of scratch work, kind of explaining everything. But to find the amplitude and your shifts, they're the same. The more complicated part of this is actually the period right here, simply because you have a fraction. If you write 2 pi as 2 pi over 1, like I did here, and then put the other fraction on the bottom, do this whole procedure that I've shown you guys to deal with fractions on top of fractions, you'll be okay.